Hello everyone, here are video solutions for 25, 26, 35, and 39. I made some sketches in CalcPlot 3D for us for 25 and 26 that should help. So we want to be above the cone, but below the sphere, and I plotted both of those. And so we're talking about this region that is above the cone, so the cone is the colored one, but below the sphere, and the sphere is the wireframe. And so what we're going to do is we're going to integrate the function of the sphere, but we're going to do it around this boundary. So think about that being our boundary. So we're going to have to figure out, sorry, it doesn't quite want to stop moving. We're going to have to figure out what the intersection of the cone and the sphere is. Okay, so to do that, we are going to acknowledge that z squared equals x squared plus y squared, and therefore x squared plus y squared plus x squared plus y squared equals 1. And so we've got 2x squared plus 2y squared equals 1, or x squared plus y squared equals 1/2. So the circle of intersection there, it has a radius of 1 over root 2. Okay, so the function we're doing this over some region, and the function is going to be, let's see, it'll be the sphere minus the cone, won't it? Right? Because we don't want to go all the way from the sphere down. We want to go sphere minus cone. So this would be the square root of 1 minus x squared minus y squared, and then minus the square root of x squared plus y squared. And we'll do dA just to start. So if we're going to convert this to polar, we are going to go from 0 to 2 pi for our angle. We're going all the way around the circle. We're going from 0 to 1 over root 2 for our radius. This would be 1 minus r squared, and then this would be minus r. And we don't forget the Jacobian, put the r in there, and then we have dr d theta. Okay. So this is going to be the integral from 0 to 2 pi of 1 d theta times the integral from 0 to 1 over root 2 of r root 1 minus r squared minus r squared. Okay. And that's, of course, dr. All right, so this one is just 2 pi, and this one's going to take a little bit of work. So I'm going to treat that as the integral from 0 to 1 over root 2 of r root 1 minus r squared minus the integral from 0 to 1 over root 2 of r squared. Each of those are dr. Sorry about that. Okay, so if we let u be 1 minus r squared, then du equals negative 2 r dr, which means r dr equals negative 1/2 du. So this would turn into the integral from, let's see, when we plug in 0, we get 1, and when we plug in 1 over root 2, we get 1/2. And that's going to be root u du, as long as we have a negative 1/2 out in front. And then that's minus r cubed over 3 from 0 to 1 over root 2. All right, moving back over here, we've got 2 pi times negative 1/2 times 2/3 u to the 3/2 evaluated from 1 to 1/2. And then that's going to be minus 1 over root 2 to the 3rd over 3. Okay, let's see. I don't know. I'm going to probably need a calculator here in a minute, and I don't think my calculator is up, but we'll get it going there. So negative 1/2, and then times 2/3 times 1/2 to the 3/2. Yeah, this is getting silly at this point. Minus 2/3 times 1 minus whatever the heck that is. Yeah, I'm not even going to bother with this. Let's see, that would be, well, I'm going to bother with it, I guess. 1 over 6 root 2. Did I do that right? So it would be 1 over root 2 to the 3rd which is 1 over 2 root 2. Yeah, I'm pretty sure that that's right. Okay. So, no idea if that's right. Let's go and check it just from the beginning. dr d theta. Oh, wow, that's amazing. That's pretty cool. Okay, so that worked out just fine. All right, let's do 25. Bounded by the paraboloids. Okay, so again, we need to find their intersection. Actually, I'm going to copy and paste this down so I can get down here. All right, so we have to find where the, I did that on CalcPlot 3D as well. There we go. They're both in wireframe. So we're looking for what's in between those two paraboloids. So we're going to do the top paraboloid minus the paraboloid over the region where they're intersecting. So let's say we've got 3x squared plus 3y squared equals 4 minus x squared minus y squared. Or, so this is our intersection. So it's a circle of radius 1. So that's nice and convenient. So we're going to have the integral from 0 to 1 and 0 to 2 pi. And if we're taking the downward opening 1 minus the upward opening 1, it would be 4 minus x squared minus y squared minus 3x squared plus 3y squared. So that's 4 minus 4x squared minus 4y squared. Or 4 times 1 minus 1 minus r squared, we could say. Okay, so let's have our 4 outside, and then we'll do 1 minus r squared times the Jacobian d theta dr. Okay, so we'll do the integral from 0 to 1 of r minus r cubed dr times the integral from 0 to 2 pi of 1 d theta. This shouldn't be too bad. 4 times r squared over 2 minus r to the 4th over 4, evaluated from 0 to 1, times 2 pi. So 4 times 1/2 minus 1/4 times 2 pi, 4 times 1/4 times 2 pi. Okay, we should get 2 pi. Let's go and check that one with the solutions. What is this? 15.4 text solutions. Where do we see them? There we go. And we're looking at number 26. Is it 2 pi? It is. Cool. All right, done with those two. Let's look at 35. The swimming pool is circular with a diameter of 40 feet. Go for a moment. Okay, this 35 is a really cool question. I want to work through it in as much detail as I can. So the swimming pool is circular with a 40-foot diameter. The depth is constant along east-west lines and increases linearly from 2 feet at the south end to 7 feet at the north end. Find the volume of the water in the pool. Okay, so let's draw the overhead view of the pool where we have a 20-foot radius. Okay, now if we think of what's happening with the depth is constant this way, so constant depth that way, but it increases from 2 feet at the south end. So the depth here, or we'll say z equals -2 at that point, but here z equals -4. We're going to try to find the volume. So let's look at this as if we're looking at it from the side, so that we're seeing this y and z axes. So let's see. So we're ignoring x, which means that at a distance of -20 this way, we're at a depth of 2. That's 2 feet. But at a distance of 20 this way, we're at a depth of 7. So the pool looks like that, basically. This point here would be the point 20, -7, and this is the point -20. -7 minus -2 over 20 minus -20, -5 over 40, or -1/8. So the equation of this plane is z equals -1/8 times y plus 20 minus 2. Yes, that'll work fine. Okay, so z equals negative 1/8 y minus 5/2 minus 2. So z equals negative 1/8 y minus 9/2. Yes, okay, that's the equation of the bottom of the pool. All right, so we're going to do a double integral over this region of the function negative 1/8 y minus 9/2. The region is a circle. So we're going to say the radius will go from 0 to 20, angle will go from 0 to 2 pi, and our function will be negative 1/8 r sine theta minus 9/2 times r d theta dr. Okay, let's see if I can solve this by hand. All right, integrating with respect to theta first. Okay, that's going to give us 1/8 r squared cosine theta minus 9/2 r theta, evaluated from 0 to 2 pi dr. Okay, so we've got 1/8 r squared cosine 2 pi minus 9/2 r times 2 pi minus 1/8 r squared cosine 0 minus 9. Okay. All right, so we've got the integral from 0 to 20 of 1/8 r squared minus 9r pi minus 1/8 r squared. Oh, that's interesting. Okay, so those are gone. And we've got then negative 9 pi times the integral from 0 to 20 of r dr. So negative 9 pi times r squared over 2 from 0 to 20. Okay, so that's 400 over 2. That's 200. So we got negative 1800 pi. The reason it's negative is because the depth of the water is below. So our volume is 1800 pi cubic feet. I like that problem. I think it's pretty cool. Okay, 39 is our last one. We have here, we're in the first quadrant, so I'm not going to draw anything else than that. So this is going to be my radius 2, and this is going to be my radius 1. Okay, so we're going from 1 to 1 over root 2. All right. Or sorry, 1 over root 2 to 1. There's y equals x. So we're talking about this section right here. And it's this piece. So this region corresponds to the first integral. Let's highlight these. That corresponds to this region. Okay, then from 1 to root 2, it's going to be here from 0 to x. Okay, so this region corresponds to this section. And then we've got the last one corresponding to here. All right, so putting all that together, we're taking the integral from 0 to pi over 4 and 1 to 2 of r cosine theta, r sine theta, r dr d theta. Okay, it's the integral from 0 to pi over 4 of cosine theta, sine theta, d theta, times the integral from 1 to 2 of r cubed dr. Let's write the first integral as 1/2 sine 2 theta d theta. And then we can start evaluating the second integral. So we got negative cosine of 2 theta with a 1/2 in front. Got the other 1/2 there, evaluated from 0 to pi over 4. That's negative 1/4 times the cosine of pi over 2 minus negative 1/4 times the cosine of 0. And that's 0. So this is positive 1/4. And then we've got 16/4 minus 1/4. So that's 15/4. Okay, so we've got 1/4 times 15/4, which I get 15/16 as my answer.